Hello, everybody. This is Sunday. It's April 3rd, and we are headed into Module 12 of our online astronomy course. Now, before I start talking about Module 12, there's a couple things I want to tell you about. And the first one, most importantly, is that this coming week, you'll have your third exam. Exam 3 opens up on Monday, that's April 4th, and it will close next Sunday on April 10th. So in between those, you can take the exam. It works the same way that it did before. You can take the exam twice if you would like to. As before you take the exam, it's going to be, you take it on Canvas at home. You'll find exam 3 right between modules 11 and 12. So good luck on that. I hope it all goes well for you. And as always, if you have any questions, please let me know. Now, I want to share with you some pretty exciting astronomy news. And so let me just pull something up here. This says that a record has been broken because the Hubble Space Telescope has spotted the farthest star ever. This star, the light from this star, started coming to us when the universe was less than 1 billion years old. It's now 13.8 billion years old. So this star is incredibly far away. Light has been traveling for about almost 13 billion years to reach us. And so we're looking at a very, very distant star. This is really exciting for a lot of reasons. And instead of telling you about it, I want to play a short video here. And so there's a link to this video also right on the module page, but let me just play this video for you.
NASA's Hubble Space Telescope has established an extraordinary new benchmark, detecting the light of a star that existed within the first 1 billion years after the universe's birth in the Big Bang, the farthest individual star ever seen to date. The newly detected star is 12.9 billion light-years away, meaning that the light took 12.9 billion years to reach Earth. The previous record was 9 billion light-years away. Normally at these distances, entire galaxies look like small, dim smudges with the light from millions of stars blending together. But the galaxy hosting this star was magnified and distorted by gravitational lensing into a long crescent that astronomers named the Sunrise Arc. Gravitational lensing occurs when a tremendous mass warps the fabric of space, creating a powerful natural magnifying glass that distorts and greatly amplifies the light from distant objects behind it. The combined mass of a foreground group of galaxies created a lens that allowed astronomers to see this distant star. After studying the galaxy in detail, they determined that one feature is an extremely magnified star that they called Earendel, which means morning star in Old English. The research team estimates that Earendel is at least 50 times the mass of our Sun and millions of times as bright, rivaling the most massive stars known. Earendel existed so long ago that it may not have had all the same raw materials as the stars around us today. Studying Earendel will be a window into an era of the universe that we are unfamiliar with, but that led to everything we know today.
And Earendel is exciting because it may be a population 3 star. That's a star that is among the first stars ever made, and that those stars would have no heavy elements yet, because heavy elements are made inside stars. And with Earendel, there may have been no previous generation of stars to make those heavy elements. We've never found one of those stars before, and this might be a first generation star, a population 3 star. That would really be exciting. So that is the space news. And let's talk about Module 12. Module 12 is about our Milky Way Galaxy. And you can see it here behind me. This was taken in Capitol Reef National Park. It's the Temple of the Sun and the Moon. The Temple of the Sun is over here on the left side of the screen. The Temple on the Moon is that right there on the right side of the screen. And you can see the Milky Way arching across the sky. Now this is taken with a very wide angle lens. And so the Milky Way looks like it's curved, but it's really not. It goes straight from the eastern horizon all the way across the sky to the western horizon. And so that's what you're seeing here. This is our galaxy, our Milky Way Galaxy. It was known since ancient times when some people, it looked like a road across the sky, a road of spilled milk, and they call it the Via Lactea, and which means the Milky Road. And way is another common road. I'm sorry, way is another common word for road. And so it came to be known as the Milky Way. But there it is, stretching across the sky. It completely encircles Earth. And all the stars that we see in the sky, all of the individual stars that we see in the sky belong to our Milky Way Galaxy. There's several hundred billion stars in our galaxy alone. So, and you'll be learning all about our galaxy. Now, what does our galaxy look like? What is the shape of our galaxy? Well, just the fact that you can see our galaxy in a band that goes from one side of the sky all the way over to the other side of the sky tells you that the stars aren't evenly distributed throughout space. And in fact, the stars in the Milky Way are in a disk, sort of like if they were located on the surface of a plate. And our sun is in that plate. And so when we look with our eye just along that plate, then we are looking in one direction. If we're looking along the plate, then we can see stars. But if we're looking up out of the plate, then we don't see nearly as many stars. So it's sort of like if this were a pizza, then and we're living on a pepperoni in the pizza there. We're living on a pepperoni. Then we have a pepperoni's view of a pizza. We're in the pizza. And so if we look along the pizza, we see pizza. Or if we're in our galaxy, we see stars looking along the galaxy. And up out of the galaxy, we don't see stars. And so that's why we see this band of stars going from one side of the sky all the way over to the other side of the sky. Now, our Milky Way is about 13.6 billion years old. Our solar system is only about 4.6 billion years. So we're sort of latecomers to the Milky Way. And where are we in the Milky Way? How big is the Milky Way? Well, again, if the Milky Way were this plate, then this plate would be from one side to the other, right across the plate. That would be 100,000 light years. That's a huge distance, 100,000 light years. And really, to measure galaxies, we are going to measure distances in thousands of parsecs. And 1,000 parsec is called a kiloparsec. And a kiloparsec is 3,260 light years. So a kiloparsec is a huge unit of distance. And our galaxy, from side to side, is about 30 kiloparsecs wide. About 30 kiloparsecs from side to side. Where are we in this? We are about, if this again is the galaxy, if here's the center, then our sun is about a little bit more than halfway from the center. We are about 8 kiloparsecs from the center of our galaxy. That's about 26,000 light years from the center of our galaxy. So we're out in the suburbs of our galaxy. Well, how in the world can we know that? How do we know where our solar system is in the galaxy? Well, about 80 years ago, there was an astronomer, Harlow Shapley, and he was studying pulsating stars in globular star clusters. Remember that globular star clusters are these huge collections of several 100,000 stars. And he found pulsating stars in those star clusters. And those star clusters are not just spread randomly over the sky, they're all concentrated toward the center, around this constellation of Sagittarius, around the center of the Milky Way. And he figured, well, that means the center of the Milky Way must be at the center of that collection of globular clusters, because they're all orbiting the center of our Milky Way. And since these are pulsating stars, he was able to use the Leavitt law, the period luminosity relation, to find out the distance to those stars. And the distance from the center of those globular clusters to the sun is about 8 kiloparsecs. So that is the distance that we are from the center of the Milky Way Galaxy. So you'll learn all about the Milky Way Galaxy in this. You'll learn about where stars are formed. If you take a look in this, this picture, you'll notice that there are some pink glowing regions. And those pink glowing regions that you see along here and maybe a little bit down here, those are clouds of glowing hydrogen gas. And they're glowing because these are the locations of hot, bright new stars that are causing that hydrogen gas to glow, that pinkish glow. And if you remember the video on spectra, where we looked at that glowing hydrogen gas in the gas tube, it was glowing the same pink. And so that tells us these gas clouds are in the spiral arms of our Milky Way Galaxy. Our Milky Way Galaxy has spiral arms. It's not a uniform disk of stars. It has a spiral structure. And these clouds of newborn stars are in the spiral arms. So that tells us that stars are born in the spiral arms of our galaxy and in many other galaxies. So you'll learn all about that, and you'll learn about what's going to happen to our galaxy. Well, it's really interesting because if you take a look at this diagram, this background picture of the Milky Way that I have, I said that all of these stars belong to the Milky Way, and they do, but there's one object here that is not a star. And if you take a look, you can see it right over my shoulder on the left side of the screen, right there. That is the Andromeda Galaxy. That is the nearest large spiral galaxy to our own. And as it turns out, we are slowly approaching the Andromeda Galaxy. And in about 5 billion years, we will merge with the Andromeda Galaxy. And so by that time, the Andromeda Galaxy is going to dominate the night sky, and it will just be a spectacular sight. Now, stars are really far apart in galaxies, and so when two galaxies collide and merge, stars don't actually bump into each other because they're so far apart that the stars just go past one another. But the gas in the galaxies collide. And you can tell that galaxies have lots of gas and dust in them because you can see it just by looking. If you take a look at all of these dark clouds that you see here, all these dark regions where maybe it looks like there are no stars. No, those are clouds of gas and dust that are all over our galactic disk. And so when we collide with Andromeda, those clouds are going to collide, and that will really create some celestial fireworks. But that's not for 5 billion years. So we have a long ways to go until then. Finally, let's take a quick look at Stellarium. There we go. Here's Stellarium. And if we take a look here, you can see we're looking to the southwest. This is actually on April 8th, and April 8th is going to be Friday. And this is just a real pretty scene. You might notice that Betelgeuse and Sirius all during semester, every time we've gone out to look at the night sky, Betelgeuse and Sirius have been further and further westward. And that's because each day the sun moves a little bit more eastward along the ecliptic. And as summer approaches, the sun will be moving through the constellation of Gemini up here, which is where the moon's going to be, this almost quarter moon. Saturday is the quarter moon, so this almost quarter moon is in the constellation of Gemini. Here I'll just put the star line, the constellation lines up so you can see Gemini up there. So right now, that's where the moon is. But by the time summer comes, it's the sun that will be among these stars right here, Gemini, Cancer, and so on in the zodiac along the ecliptic. But go out and take a look at this beautiful scene. If you get a chance, this is around 9 o'clock at night. And now that you've finished learning about the stars, you can appreciate that Betelgeuse is a red giant star, for instance, and so is Aldebaran over here. And you can appreciate the star clusters. Here are the Pleiades and the Hyades that were clustering around the face of the bull Taurus. So go out, take a look, and I hope you enjoy learning about our Milky Way Galaxy. It's really fantastic. So as always, if you have any questions about this material or about the upcoming exam, please let me know. Send me an email. We can talk via Zoom. We have a meeting in my office. But have a good week. Good luck on the exam. And I will look forward to seeing you next time. So until then, have a great week. Bye-bye.